Here's our problem. Vector v has an initial point of -5, 8 and terminal point of -8, 7. So let's plot the vector. We are going to click and draw the directed line segment using this information. So -5, 8 means go to the left 5 and up 8. And I'm going to click at that spot to form the initial point. And I'm going to point the arrowhead to the terminal point, -8, 7. So I'm going to go -8 and go to 7. Once you have plotted the vector, they're asking you to move the vector so that its tail is at the origin. So the tail is this initial point. So I'm going to click my vector and I'm going to move it to the origin and release it. And once you release it, you're going to notice that this box is going to open up with some information that we need to fill out. Now, the reason we have moved it to the origin, because this vector can be located anywhere on our plane here, but visually it is so much easier to determine the horizontal and vertical distance that this green vector has traveled. So at the origin, you will count the horizontal units traveled, which in this case would be 3 units to the left. So I'm going to come over here and type -3, -3. And then the second space, or the y value, is the vertical distance traveled. It would be downward 1 unit. So we're going to establish that by typing -1 for down 1. Okay. Now, magnitude of v, you guys have already talked about that at length, is going to always be represented by 2 bars around the name of the vector, which names of vectors are usually represented by either 1 letter or a 2-letter combination. So in this case, they're calling it vector v. And so always remember those 2 bars just means find the magnitude. And magnitude is just a very fancy word for how long is that vector. We also notice that our vector forms a right triangle. So if we look at this vector in this sense, the vector v look like this, okay? And we already established that it traveled this distance, -3, and it traveled this distance, -1, okay? So do you not notice that this here is a right triangle, okay? And because it's a right triangle, we are able to find the length of that green distance, because that in essence is just our hypotenuse. And when you are looking for the length of a hypotenuse, all you use is the Pythagorean theorem to determine that, which we all know is merely just a squared plus b squared equals c squared. So let's go find our c value. Our green vector is our c value. So we're not going to write c though. We're going to write the length of our vector is the square root of a squared plus b squared. Our a squared is going to be our -3 squared plus our b squared is going to be -1 squared. And then we are going to simplify. -3 squared is 9. -1 squared is 1. And that gives us the square root of 10. And that you will come over here and type square root of 10. Now, if your radical needs simplifying, I need you guys to do that, okay? And what I mean by that is sidebar here on this, okay? So, for instance, I'm going to come over here and let's say you ended up with the square root of 32. I'm totally making this up, okay? So I need you guys to factor. So 32 is divisible by 2, 2 times 16. 16 is also divisible by 2, 2 times 8. 8 is divisible by 2, 2 times 4. And you keep just doing that, okay, until you have all prime factors. And we did this last year, so hopefully this is just you refreshing your memory, okay? So the square root of 32 had 1, 2, 3, 4, 5 twos. So I'm going to write it out here on a line here so it's visually more appealing into understanding what I need you to do. So once you have factored it out into all prime factors, you are looking for your pairs, as many pairs as you can capture. And in this case, you were able to find 2 pairs of 2s, which will leave the radical, okay? And they leave the radical as 2s because the square root of the first pair is square root of 4, which is a 2. A square root of another 4 is a 2. So you will rewrite this radical as 4, because 2 times 2, these 2s, is going to be 4. And what's left inside is a 2. Okay, so 4 square root of 2 is the equivalent simplified radical of square root of 32. And you guys know that you are able to type that in the calculator to verify that they are both equivalent, okay? So 4 square root of 2 is what you would want to type as your final answer in Delta Math whenever you simplify, okay? But square root of 10, you'll notice it is fully factored, it's in prime form, because square root of 10, if you broke it down, it's merely 2 times 5, and 2 and 5 are both prime factors, and it cannot factor any further. So square root of 10 is our final answer. Okay, so moving on now to direction V. Theta V. What is theta V? What is the direction of our vector V? So going back up to the drawing upstairs here, the direction V is, let me look for another color here. Let's use purple. Okay, the direction V, what they're asking you to find is if you were to measure the rotation of your angle from standard position is this line right here, okay? And I were to measure the angle all the way to the vector, that means if I start measuring my angle and I rotate, and I keep rotating until I stop at my vector, that distance traveled, that is the vector direction that you're looking for. How far is that purple distance? What's that measurement in degrees? Now, I definitely know it's more than 180 degrees and less than 270, because this is my 180 marker. This is my 270 marker. So I know it's trapped in between those two in quadrant number 3. Okay, I know that for a fact. But how do I find that measurement? Well, what you're going to do is actually you are going to focus on the distance right here that I'm drawing in black of this right triangle. This distance, I'm going to call it phi. Okay, I'm not going to use theta. I'm going to use the theta symbol, but the line is a little bit tilted, okay? So I'm going to redraw this triangle down here so I can easily draw a little bit clearer as to what's going on and explain to you what I'm talking about. So here's this one, and then I'm going to pull a green. Let's see, where's the green? Okay, now here's what I'm going to have you do. I'm going to need you to look for this angle right here, okay? I'm going to have you look for that angle. And the reason I'm going to have you look for that angle, because you have some prior knowledge on trig that's going to help you. So to find that angle, notice that you have the length of the opposite side of that angle, and you have the length of the adjacent side of this angle. All right? Opposite and adjacent uses the ratio of tangent. Okay? Opposite over adjacent. Okay? Now you are going to notice in vector land that our opposite will always be the y distance, and our adjacent will always be the x distance. Y being the vertical up and down, and the x being our left-right, the x value. Okay, so what we're going to do is substitute what we know. So the tangent of phi equals the y distance, 1, over the x distance, 3. I always use the absolute value distances, okay? So always use positive distances, absolute value distance. So drop any negatives. So my y1, my horizontal 3. So solving for phi requires me to take the tangent inverse of 1/3. I will go to my calculator, calculate the tan inverse of 1/3, and I am going to get, in this case, they want us to round to the nearest degree, so I'm just going to round to the nearest whole number. I got 18.434, so I'm going to just write 18. Now, 18 degrees is not our final answer. Recall that I told you, here we go again, drawing this triangle. You traveled this distance, and this is our vector right here. What you just found was this distance right here. But what I'm asking you to find is this distance right here. Okay? So hopefully you're realizing that what you did is you traveled 180 degrees plus a little bit more, which was this distance right here that you just found of 18 degrees. So now notice that when you are in the second quadrant, if I need you to find the vector direction of a third quadrant, notice that if I asked you to find the vector direction of a third quadrant vector, what you will need to do is add 180 degrees to the angle you found, which in this case is 198 degrees. So I'm going to come over here and type 198, and we are going to submit our answer, and we got it correct. So as a summary of last semester, just in case you haven't remembered or it's not fresh in your memory, here is the formula for the 4 quadrants. Okay, I apologize for that noise. Here we go. If your vector ends up in the first quadrant, I just want you to use the angle that you found in the first place. Okay? If your vector ends up being in the second quadrant, I need you to do 180 degrees plus the vector you found when you did tan inverse. Okay, let me put that in purple to be consistent. All right, 180 plus. Oh my goodness, not 180 plus, my bad, 180 minus. I am so sorry. Didn't mean to confuse you. Then in the third quadrant, if you're looking for the vector v, in this one, like the problem we just did, you will do 180 plus the angle you found after doing tan inverse. And in the last quadrant, hopefully you're already speaking it out loud because you remembered, you will do 360 degrees minus the vector you found. And that, my friends, is how you are using the information from last semester of trig in this semester. So make sure you memorize those again, and good luck with these problems. Thanks for watching.